All right, I'm going to show something really awesome, how we're using a load cell to capture analog voltage, which can then be calibrated into pounds or kilograms. So the setup we got here is 3.3 volts on the power supply. Uh, we basically have, um, so how these load cells work is there's a strain gauge inside of it, which works by when you press this or pull it, so there's going to be a very slight change in resistance. And then inside of this puck thing, there's something called a Wheatstone bridge, which some dude named Mr. Wheatstone a long time ago found that you can measure a change in resistance and have it output a change in voltage by using like a diamond shape of resistors. And I just Google it, it's real fancy. But the gist is at the end of this, we're going to have a slight voltage change when you press this. So what's happening here is we're going to take that slight change and we're going to feed it into an operational amplifier. Into the non-inverting input, we have 10K resistor, and on the feedback, we have 100K resistor. So we're basically going to be 10 times multiplying the signal here, and then we're going to be feeding that signal into another 10 times multiplier, and basically then measuring the output. So what happens is we're going to squeeze it. So put this in a vise, and I'm going to start turning it. You can see as you turn and tighten the clamp, you're going to see the voltage go up, and it's going to go to the saturation point, which is 3.3 volts. It's like pretty close there. But so then when I back it off, it goes back. And what you can do is you can say, hey, you're going to put 20 pounds onto this, measure the voltage, get 2 points, and then it scales linearly with the voltage. So that is how you use a load cell. See ya.